Hello everyone. So welcome back to my channel, BBT. Today we will solve this problem 3, lead code 78. So the problem name is actually subsets. Okay. So mention here subsets is the name of the problem. And what we will cover today, we will cover that pick not pick concept. Okay. One thing is this. Before that, we will learn about a little bit of definition steps, set and subset, what is set and what is subset, how it is related with array, and how it is related with like string, what is called it. Okay, so this thing and what is power set, uh, and yeah, pick not pick consent and concept, and yeah, we will solve this problem using recursion. So let's uh, let's start with this set and pick and not pick concept, and we will discuss about solving this intuition and recursion. Okay, and then we will talk about time complexity and space complexity. So yeah, we will cover this. So uh, what is set? Okay, so I will give one example here. Okay, set. So actually by the definition, set is a like collection of unique elements. Okay, so what do you mean by unique elements? Okay, let's say you have an array. Okay, 1 comma 2 comma 2, and there is a one array 1 comma 2 comma 3. Okay, so we can call this as a set. We cannot call this as a set. This is not a set. Sorry, this is not a set, and this is a set. Okay, why? Because there are duplicates elements and they are unique elements. Okay, so the number of elements doesn't matter. It can range from 0 to infinite, and so but the condition which should be satisfied that every element should be unique. Okay, though generally set representation is one comma like this within the curly bracket, but we can treat a array as a set here. Okay, so we have talked about a set. Now we will talk about a subset. What is a subset? So subset. Okay, so uh, let's if we call set as a unique collection of five elements. Okay, so subset is a smaller set of this set. Okay, if we say there is a set which is containing any elements from this set. Okay, then it will be called subset of this set. Okay, so this is the definition, and that number of elements. Okay, it can have like all the elements that are present in this set. It can have it can have none elements from this set, but yeah, it should not have any element which is not present in this set. Okay, let's say it cannot have a 4. If this is a 4, then this is not a subset of this set. Okay, if this is a 1 2, then this is a subset. If this is empty also, then it is a subset of this set. Okay, and it can have a like complete set. Okay, this is called, it can also have like subset. This can also be a subset, this can also be a subset, this can also be a subset, but this cannot be a subset. Okay, okay, so we have talked about subset. Now we will talk about power set. Okay, so I will take this set 1 comma 2, and if we list down all the subset of this. Okay, okay, so this is all the subset, this is all the value subset which are there for this is a set, and this is all a like this is all a subset. Individually they are set, but they are subset of this set. Okay, if we enclose them in a curly bracket, then it means it is also a set. Okay, it do not have any duplicate element. This is unique, this is unique, this is unique, this is unique. So this set will we will call as a power set. Okay. So yeah, so we have talked about set, subset, and power set. Now let's go to the question. Okay, so the question name is only subsets. Okay, so here we have a array. Okay, given an integer array. Okay, number can be from like negative. Individual like numbers can range from minus infinity to infinity. Okay, not infinity, of course, minus 29 to 29. Okay, given an integer array number of unique element, return all the possible subset means you have to return the power set. Okay, so in case of array, okay, in case of array, okay, what is a subset? Okay, there are two words which we use for like array. One is a sub array and one is a subset. Okay, so then any if you pick any element from this one, then it will be called subset. Okay, and for the sub array, the definition changes that the element we choose should be contiguous. Contiguous means it should be continuous. If we pick the element, then it should be continuous in the continuous order. Okay. In this, we can pick randomly. Like we can pick from here one, we can pick some three. Okay. So 1, 3 can be a subset. Okay, but 1, 3 cannot be subarray. Okay. So this is a like a small discussion that needed to be made. Okay. So what we have, we have an array. Okay, with the unique element. Okay, array is like this is a array. Okay, if you see this array, okay, then I have said that if an array contains unique elements, then it is also called a set. Okay, then it is a set. Return all the possible subset. All the possible subset, it means the power set. So for this 1, 2, we have to return this power subset. Okay, so this is like and this set must not contain duplicate subsets. It means that here, if you are saying 1, 2, then you should not say 2, 1 because it is a duplicate. Okay, so every number like in a set, every element should be unique. So if 2, 1 and 1, 2 is a duplicate, we will consider this as a duplicate. Okay, so we know what we have to return for the given input. So let's say 1, 2, 3. Okay, so we have to return this 8 possible subset. Okay, and this is a like yeah. So now we will talk about pick and not pick concept. Okay. So again, if you see this 1, 2, okay, and all the possible subsets, okay. So this have a 2 element, okay, and this power set have a 4 element, okay. So n equal to 2 and power set of n have 4 elements. So it is kind of 2 to power, sorry, it is 2 to power n formula. Okay, so if you have n unique elements in array, then you have a 2 power n sub power 2 to power n overall subset for that, and that will be the number of elements in its power set. Okay, so like you can take one more example. Let's say one. For one, we have empty set and one is itself. Okay, so this is a power set. So it have a 2 element. For n equal to 1, 2 to power 1, it have a 2 elements in its power set. Okay. So let's uh, take this one. Okay. 1, 2. Okay. This is a one set. Okay. This is a second. This is a third. This is a fourth. So yeah, as we can see, for n equal to 2, we have 4 elements. Okay. And we have four subsets, okay, in its power set. So if we let mark it as something, okay, so let's say how, let's say focus on this subset empty one, okay. How this is got generated? It got generated when we haven't picked anything from this, okay. And if say, and likewise if we see this, if we have like picked this, and if we haven't picked this, then this subset got generated. Similarly, when we picked this and we haven't picked this, this subset got generated. For complete 1 comma 2, we have picked both of them, then it got generated. So basically we can see that all subsets can be generated by pick and non-pick. If we like, so if we see this, okay, we haven't picked both of them, then the empty subset, okay. If we have picked this, we haven't picked this, okay, then it is a this subset. If we haven't picked one, we have picked two, then this is a like third subset. If we have picked both of them, then it's a fourth subset. Okay. Let's let's mark cross as a 0 and tick as a 1. Okay. Then it is a 1 1 1 0 0 1 and 1 1. If you see this, okay, then this is a sorry 0 0. Okay. 0 0 1 0 0 1 and 1 1. Okay. If you see this, then this is a binary representation of 0. This is a binary representation of 1. This is a binary representation of 2, 1. This is a binary representation of 3. Okay. So 0, 1, 2, 3. For if you take the binary representation of all, okay, and you take 1 as a pick and you take 0 as a not pick, then you can generate all the powers, all the subset for any given array or any given set. Okay. So basically, this is all the subset are are a binary representation only. Okay, so for our understanding, we are taking as a pick and not pick concept. Okay, so how you can generate all the subset for any set? Gen- You have at any point you have two choices. You can either select that element or you can not select that element, and you will proceed further. Either you can select this element or you cannot, and likewise you will look likewise you will look for all the possible numbers till 2 to power n, then you can generate the all the subset. Okay, so there's one approach where you like approach one. I will not solve this approach one. This can be covered in a different video. Okay, where you will run a loop. Yeah, you can run a loop from 0 to 2 to power n. Okay, and here you can do the binary representation of every number. For one, you can select that element. For 0, you will not select that element, and you can likewise generate all the subset. But here we will focus on approach 2. Okay, so approach 2 is okay, you will do the recursion here. Okay, okay, so let's say you have an empty set. Okay, then you have picked one. Okay, pick one. uh, then you have picked 2. It leads to 1 comma 2. You have picked 1, but you haven't picked not pick 2. Then you will end with this. If you haven't not pick 1, okay, and not pick 2, then it's an empty subset. If you have not picked one, but you have picked two, and it's a this subset. Okay. So likewise, you have generated all the four subset using pick and not pick concept. Okay. So now here, from here, you get the idea of recursion. Okay. This is the intuition. If you have an array 1, 2, at any point you have a choice that you can pick or not pick. And likewise, if you will go on, then you will generate all the possible subset. Okay. From here, you get the intuition of recursion. Now we will solve this. Okay. Let's write the code part. So for the code one, what we had this, okay, this template. So the function name is subsets, and what you need to return, you need to return the vector of vector int. Okay. So vector of vector int means it's a list of lists. So basically it's kind of this thing. You have a this vector, you have this vector, you have this vector, you have this vector, and it is again a vector of list. Okay. Vector of int. Vector of vector of int. So you will store, you need a container to store an answer. Okay. This is the first thing. Okay. You can make it global. Okay. So now how you would think that, okay. So for any recursion, you sometimes what you want that when what when the recursion like comes in mind, then you need to think of a base case. Okay. So what is the base case here? Let's discuss that first. Okay. Okay. Yeah. So base case. Okay. So let's say you have a function. Okay. This is your recursion function. Okay. You are starting from index n. Okay. And you have n number n. You have n number in the array. Okay. So what your base case would be that if you reach this index, okay, let's say you are on this index, okay, and the total size of array is 2, okay. So you first you decide here that you will pick or not pick. Then you will decide here you will pick or not pick. Then you will reach here, okay. So when your index where you are standing here, you are standing here. Then if you reach the end of the array, okay, so it means if index, okay, if index reach to n, okay, then here you would have answer. Okay, so this is the base case. Now you want that your your answer should be present here. Okay, so let's say I am starting with a empty this is a vector of int. Okay, so it is an empty array. Okay, I can write it at this also. Okay, here you have choose that I will not pick one, I will pick one. Okay, here you choose I will pick two, and you reach the end. Okay, so when you reach the end you have answer. This is one of the answer. Okay, this is one of the answers. So you reached here at n and you want that, yeah, the answer which you have in vector, that should be your answer. Okay. So here you what you will do, you will push that temp. Okay. You will push that temp. So this is your base case. Okay. Okay. So from here on, you got an idea that you need a function, okay, for recursion. You need a temporary answer, okay, and you need an index, okay. This is that I, okay, and from there on you can start with the function, you can start with the coding. Okay, so now let's write the code first. Okay, so you have an answer vector int. Okay, let's you have a temporary answer. Okay, now let's say what is the function name generate all subset. Okay, you will call this function. Okay, here you have from in the starting you are at index 0. Okay, here, so you will pass 0 here. For n, you can pass nums, okay? And for picking and not picking element, you need to pass the array, okay? So from size also can be calculated from nums only, okay? So that's not a problem. You don't need to pass n specifically. Then you will pass this temp, okay, for storing your answer, okay? And this is enough, okay? So this is a function you need to write now. This is pseudocode kind of thing, so don't mind if I do something wrong. Okay, so what was this 0? This was index. Okay, what was this nums? This was a vector of int. What was this temp? This is also vector of int. Okay, here we want to pass this as a reference. Here also we can pass this as a reference. Okay, it doesn't matter, but what? Uh, okay, so what would be type of this generate all subset? We are not returning from this. Okay, we are not returning from this function. I think we are storing our answer here in the answer. Okay, so this will be a void. Okay, now you will write your base case. If your index I, y, okay, just understand it. This is I. If your I reaches nums dot size is a n. Okay, then what you will do? You will push your temp into the answer. Okay, this was your base case. Okay, now what should be the next step? You are standing at I. Okay, now you need to make a choice whether you will pick this element or you will not pick this element. Okay, so let's say I pick this element. Okay, so what I will do? If I will pick this, then I will store that number in my temporary n. Okay, so I will do temp dot push back nums of I. Okay, okay. When I have pushed this, okay, then again, if you see this part, okay, let's say I have pushed this temp, okay. Again, this is like a different question. Generate all the subset for that and append your answer. Okay. So now I have stored temp 1, okay, in this, like I have stored the nums of I into 10. Now I will call the recursion again into on this remaining portion, okay. Okay. So let's copy this only. I plus 1 because you have moved one index, okay, then nums, and the temp will be passed as reference. So you have stored temp, then here it is passed at the array with element 1 would be passed. Okay, now you have picked this one. Okay, you have called this. Now one option is that you won't pick this. Okay, you will pass this temp as it is in generate all subset. Okay, but currently now our temp have nums of I in it, so we need to pop that up. Okay, now again you will call this. Okay, now at the end of when every function reaches the end I equal to num size, then it will store our answer. Okay, answer dot put, and we will push it in our answer. So we have like declared answer here only. Now we will return this answer. So okay, so this is a code part. Okay, I don't think there should be any doubt in this. This is like simple pick and not pick concept. There are many questions like related to it. Again, you can solve on lead code, or I can make videos on that also. One is like subsets two, if you can check. This is like upgraded version of this problem where we have like duplicate elements in. We are generating all the power set from a non-set. Okay, so currently we have a set and we are generating all the power set, all the subset. But if we have duplicates in array, then it is not a set, and we need to generate all the subset without duplicates. Then this is a problem. This is also like pick not pick base like concept, but there's just some changes. And similarly, like combination sum, if you see, so this all are one and two both, and even the generate parentheses. If you like, if you have checked my last video, there also we have done the same kind of thing. Like we have picked parentheses, like we have picked open and not open, but there we have to like check whether it is balanced or not. So some changes would be there, but the concept would be like this one. You cannot pick, okay? So you can check out these problems. And let's discuss about the time complexity of this. So of course, time complexity, we are generating all the powers, like all the subsets of a set, and it would be order of 2 to the power n. Okay, and what be like, yeah, TC would be like order of 2 to the power n, and SC would be, we are storing all the 2 to the power n into a vector, then of course it's a 2 to the power n plus for order of n, the recursion stack. Okay. Now we can talk about recursion tree. So recursion tree is kind of this only. Okay. That you will pick or not pick. Okay. But I will I will show you something in more detail. I will like do a dry run on this function only. Okay. So yeah. We have this generate all subset. Okay. GS function, let's say we call it. We have a 0. We have nums, which is like 1, comma 2. Okay. We have temp, which is a blank. Okay. Now, what we will do? We will first we will go there. Our I is equal to I0. I is equal to nums of size. Nums of size is 2. So it is not equal to 2. What we will do? We will push our answer in this temp. Okay, and we will call this function again. Index will change, and here we will store our answer. Okay. Again, what we will do? We can let's zoom in. Okay. Again, we will go here, generate all subset. Now this time what we will do, we will pick, now we are on this function. Okay, I is not equal to nums dot size. Okay, our I is 1, we will pick this one. Okay, now index will change to 2, nums will be same, 1 comma 2, and here 1 comma 2. Okay, this is temp. Okay, now here I equal to nums dot size. Okay, 2 equal to nums dot size. Then we will store our answer. Let's say our answer is here. Okay, so we'll push 1 comma 2 here. Okay, now here is one more function. Here from here only we will return. Okay, okay, and this function got executed. This returned at this function only. Okay, now here we will not. We will, what we will do? We will pop 2. Okay, then we will return here. Okay, now Okay, we will pop 2. Okay, when we will return from here I equal to 2, answer dot push back, we have written on the like original condition. Then we will pop this 2, then we will be back here only. Okay, now this step got executed, pop step got executed. Now what we will execute? We will execute this step, generate I plus 1 nums comma temps. Okay, okay. So now this will be index is 2. Okay, nums is 1 comma 2, and here we have 1 only. Okay, yeah, okay. So you got that? What happened? We have, okay, so from the starting we had like we were at index 0, we moved to index 1, we have selected tab as a 1. Okay, we have moved to index 2, we have selected 2. Okay, now we have stored our answer here. Okay, because I reached to 2. Okay, uh, okay, so we need a return statement also here. Okay, I haven't like here only. After that we need to return also, because this was a pseudocode, so that's why I got confused. Okay, okay, so we return from here. Okay, when we return from here, okay, we were at this function only. Okay, but our temp was 1 comma 2. Okay, we have popped, this is a pop operation, we have popped it, then it becomes 1. Okay, then again we are back to back from where we started. Again we will, now we will do the next step on this. We will increase the I will be 2, and the nums will be 1 comma 2, and your temp will be 1 only. Okay, so now I equal to 2, I equal to 2, so I equal to nums of size. Now we will push our temp into the answer. Temp is 1. Okay, okay, so likewise. Okay, now temp is 1 now. Okay, now we will return to this step only. Okay, so this part is completed now. This part is completed now. Okay, okay. Now what will happen? We have written here. Now it will go here. Okay, will do a pop operation. Okay, now again another tree would come. I will explain it here. Yeah. Now again this I will like write it here only. I will, okay. So generate all subset 0 has 1 comma 2. Now this is the second part. Okay, we have written from here, we have popped one. Okay, now what we will do? Now we will not pick this one. Okay, so what happened? Generate, we will not pick this one, we will move our index I plus 1. We haven't picked this one, so this is an empty subset. Okay, now again our I is not equal to nums of size, so it will go again here. Now we will not pick. Okay, now we will pick 2. Okay, that was a different case, this is a different case. Okay, we haven't picked 1, now we will pick 2. Okay, we will move to index 2, 1 comma 2. Here what will our answer is to 2 now, because it is empty, we will pick 2. And again one more case will be there. Yes, when we will return from here, we will pop 2, we will come back to again to it again. Okay, now we will increase the I, we will not pick 2 this time. Okay, so our answer will, our temp will be answer. In both case, I equal to 2 means I equal to nums of types, nums dot size. Then we will store this answer. Okay, 2 and this empty bracket. Okay, so that's how it's a recursion tree we will generate. I think I'm not good at drawing or pen, so it might be a little tough to see, but yeah, that's all. Uh, so what we have covered, I think we have covered all the thing we have listed. We have covered subset and set and power set, pick not pick concept, intuition and recursion, TC and SC, and also we have covered like recursion tree. Okay. So that's all from my side for this problem.